So the derivative here is what? What do we know for sure about the derivative here? There's one thing you know for sure. It's positive. Over here? More positive or less positive? More. Here? Here? More. As you get closer to a vertical asymptote, what happens with that tangent line? What happens to the slope? It's approaching infinity. If you have a vertical asymptote, your tangent line gets steeper, 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 so the derivative gets closer to infinity. Keep going. Give yourself a sketch if you're not sure.
So when there's a vertical asymptote,
Not even.
Whenever there's
vertical. That would be closer to zero, right? But horizontal.
They're teachers.
I know.
I thought they were like.
Oh, the sound prime, remember that. That would be the zero. Yeah, the root f prime would be the setup point, and prime would be the root.
There is some good stuff happening out there.
Yeah.
So I'm seeing some folks struggling with the horizontal asymptote. It's not that f prime is equal to 0. Can somebody give me an example? I want a parent function that has a horizontal asymptote. I'll take anything. Any parent function with a horizontal asymptote. Arctan. Okay, you want to go big. Go big or go home. Arctan has a horizontal asymptote. Looks like that. When we talk about f prime, we're talking about the slope of the tangent line. I want to keep coming back to this idea. So if I have a horizontal asymptote, you're saying you're getting closer to this horizontal line at y equals pi over 2. What happens to the derivative? What happens to that slope? It's not that it becomes constant. If right over here my slope is positive, but now I'm less positive, what's it doing? Getting to 0? Getting close to 0. So if I have a horizontal asymptote, I'm approaching 0. Okay, my folks, relative max. Can you guys show me a relative max? Relative max, I want to see relative max. Everyone's drawing the same kind of relative max right now. I see everybody doing this thing, and I understand why. That's not the only kind of relative max out there. There's another kind. There's the sharp kind. There's the poke yourself in the eye kind. Okay, one of these is differentiable. Which one, one cut?
The one on the right.
The one on the right is differentiable. Okay, the mistake a lot of students say, they're like, oh, relative max means the derivative is equal to 0. No, because actually, you know what? Both of these are relative maxes. They're both relative maxes. Because in both cases, the function changes from increasing to decreasing. If the function changes from increasing to decreasing, then f prime over here is positive, but on this side, f prime is negative. So in calculus, when we talk about a relative max, what we're saying is that f prime changes from positive to negative at x equals c. I care greatly about that change from positive to negative. Hello, friends. Come on in. So, Real quick, 2 more minutes. I want relative minimum, saddle point, and horizontal tangent. If you need to give yourself a quick sketch of the graph, go for it. But I want to be able to talk in 2 minutes. What makes a relative min, a saddle point, horizontal tangent line. Go for it. I just want to say hello to my friends. Not
Okay, so you know how what is the relative maximum? It goes like that, right? It first increases, it goes starts from the bottom and goes up, so it increases, then it decreases to the bottom.
Jen's like resuming her seat on Team Pax.
It changes from positive.
I think the key right now is give yourself a little sketch to look at.
Positive. Oh, the slope is positive. The slope is positive, and then right here you see the slope being negative.
And what's that? What did you keep?
Oh, okay, so triangle is change, like the change in slope. Then plus is the positive to negative.
Oh.
I like most of what I see. Love it.
Horizontal tangent? Yeah.
All right, I want to stop the action real quick in 3, 2, 1. You guys show me relative minimum. What does that look like? What does that look like? What are my options for relative min? Okay, I'm seeing a lot of this, right? This is like the Algebra 2 pre-calculus version of relative minimum, but we know something else. There's another kind of relative minimum, and it's this kind over here, right? The sharp point, the fancy word is? So say it like an angry German? Cusp point. It's a cusp point. So if this is a relative minimum, Alejandro, what happens with the derivative if you have a relative minimum?
It changes from negative. Yes, negative function. The function.
No, it's even worse now. The original function is changing from decreasing to increasing. Brianna totally saw you whispering in. Okay, so f is changing from decreasing to increasing. Alejandro, what happens with f prime?
F prime changes from increasing.
It changes from what?
Negative to positive.
Thank you. From negative to positive.
At x equals c.
At x equals c. Can you guys show me saddle point? Now that was like the new vocab word from yesterday. Drop for me. Saddle point, saddle point, saddle point. Okay, see, I'm seeing a lot of this. That's not a saddle point. That's a, begins with an H. Ends in a horizontal tangent line. Thank you. That's a horizontal tangent line. I'm asking for a saddle point. Saddle point. What does a saddle point look like? You guys might want to look at Alejandro this time. He actually knows what he's doing this time. One more time. Right, the saddle point, what makes a saddle point is it does that. Or it does that thing. So at a saddle point, what do I know for sure about the derivative? You have a horizontal tangent line, the derivative is going to be equal to 0. Now here's the thing that I want to be really careful about. There's actually something else that's happening. At a saddle point, if this is my saddle, before the saddle point my function's increasing, after the saddle point my function's increasing, what happens with the derivative? F prime over here? If the pink is increasing, then the derivative is positive, and the derivative here? Still positive. Over here? Negative. Okay, the function is decreasing, so the derivative is negative. So it's that f prime is equal to 0 and f prime does not change sign. Does not change sign. You need to have both pieces. Last one, horizontal tangent line. Show me horizontal tangent line one more time. Horizontal tangent line looks like that. What do we know about the derivative? 1 Kai? If you have a horizontal tangent line, Juan, what do you know? Horizontal tangent line. What's the... Oh, I was wondering if you were thinking or you didn't hear me.
I didn't hear you.
Yeah, okay, but everybody else did. You guys were so patient. Thank you. So the function has a horizontal tangent line. What do you know about the derivative?
It exists.
Oh, yes, it exists, and even better, you have a horizontal tangent line. Somebody help me out. What else do you know? What else do you know? You have a horizontal tangent line. Miguel, what else do you know? F prime equals 0. At a horizontal, I think you're confusing tangent line and horizontal asymptote. Okay, we're at 0. Can I let you guys in on a little secret? Tomorrow, when you walk in, you have a 4-minute quiz. That 4-minute quiz has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 questions on there.
The same ones.
It's the same ones.
Yay.
Because this thing that we're doing right now, this unit on like the derivative as a function, f prime, f double prime, and the antiderivative, is 25% of the questions on the AP exam in 231 days from now. 25% of the things that we are going, of that test, is what we're doing in the next 2.5 weeks. I need to get this seed planted deeply. So tomorrow when you come in, a surprise quiz. I know right now it doesn't feel like a surprise quiz. I bet at least 12 of you are going to come in and be like, what? What quiz? Yeah, Miguel, thank you for being there for me. All right, here's my favorite part. I'm so glad we have guesses for this. It's time to color.
Yay.
Oh my God, we're going to color a little bit. We're going to use the calculator a little bit. I'm going to get great observation feedback. All right. So I need calculator and I need markers. And I need smarticle particles. Need those smarticle particles. Oh my God, Janaea has got the pack of colors and she's not going to share, I'm sure. Here's what I want to do. I want to take all these vocab terms that you've got and I want to put them into practice. So, I've got my graph of f of x. My goal is to come up with the graph of f prime. Everybody with me? We get the graph of f. I want to come up with a sketch for the graph of f prime. Yesterday, you guys were oohing and ahhing as we did this on Geometry Sketchpad. Now, no technology. We're going to do this like real mathematicians would. So, I want you to take 30 seconds. Look at this graph. And then turn to somebody near you, tell them all the things you know about this graph, all the calculus things that you know about this graph. 30 seconds, go for it.
Two? No, wait. There's a root at yeah, two.
All the calculus things. All right, closing out in 5, 4, 3, 2,
That's the only thing.
and 1. All right, folks with me. I've got the graph of f of x in front of me. I want things that you know for sure about the graph of f prime. Let's get some hands on this. Things that you can tell me about f and what this means about f prime. Josue, what do you know about f?
It has a relative maximum at x equals 0.
Go ahead.
No, but f of x has a relative maximum at x equals 0.
Is everybody okay? F has a relative max at x equals 0. Everybody's good? So, okay, good. I've got like that. I've got like a little relative max over here. Does anybody know anything about what the graph of f prime must do? F has a relative max at x equals 0. Miguel, what must f prime be doing?
F prime must have a root at x equals 0.
Even better than a root. If f has a relative max, Jaylene, what was it that you just said? Oh, okay, sorry. F has a relative max. Juanco, what do you know?
Wouldn't it have a double root at back?
I don't think so. F has a relative max. Go back to your notes on the first page. When F has a relative max, this is why I wanted you to have access to those. If F has a relative max, what's F prime doing? Brianna, what's it doing? If F has a relative max, so I'm going to use black to be the graph of F, and the pink is going to be the graph of F prime. If F has a relative max over here, what's happening with F prime? F prime makes a change from positive to negative. Does anybody know anything else? Look at that graph of F. What else do you see? What does it tell you about F prime? Love to hear from some folks I haven't heard from yet. Janaea. Okay, hold on. I hear you saying that there's a relative min. There is a relative min. It's the way that you're describing the location that's a problem. F has a relative min at x equals. You're going to tell me the x value. At x equals 2, so f prime changes from negative to positive. F prime changes negative to positive. Good. What else? Other things that you see in the graph of f. Fabricio?
There's a saddle point.
There's a saddle point. Now, remember, a saddle point, you like increase, you flatten out, you increase. This guy actually doesn't have any saddle points. What else, though? There are other things that you should see. Melissa, what else do you see?
It has two horizontal tangent lines.
You have 2 horizontal tangent lines. Where are those?
At the relative x and the relative.
Okay, you've got a horizontal tangent line and you've got a horizontal tangent line. So what does that tell you about the graph of the derivative? I'm going to have roots. So if I have a horizontal tangent line here, I have a root here. I have a horizontal tangent line here. I have a root here. Jasmine, you okay with that? Okay. Usually I start the conversation with horizontal tangent lines because then I can get roots really easily. Okay? I could also describe the graph of f. What's f doing over here? Increasing, so the derivative is positive. I could say over here we're decreasing, so the derivative is negative, right? So I need my graph to be negative, right?
Yeah.
Increasing, so positive, passes through 0, looks like that. What I care about is this. I don't want you to worry about, but how far down do I go? Don't let the OCD take control right now. What I care about is if the graph has a horizontal tangent line, the derivative has a root in the same place. So horizontal tangent line, got a root. Horizontal tangent line, got a root. When the graph of f is increasing, the graph of f prime is positive above the x-axis. Decreasing below the x-axis. Increasing above the x-axis. Brianna, what's up?
So it doesn't matter if, so the derivative won't have to be the same graph as the original function?
It might be. I love the way your brain is going right now. It could be. Anybody know the degree of this first one? Go back to pre-calculus thoughts. What's the degree? What's the degree, Salma? Look at that graph. You know that graph. Degree. The degree means like the highest exponent. This first one?
1, 3.
Okay, I feel like we're at an auction. Alex?
I believe it's 3.
This is degree 3. This is the fancy word for this? Cubic. The degree of f, f is cubic. Down here, f prime? It's quadratic. What happens with the power rule? You bring the power down and then reduce the power. We went from degree 3 to degree 2. Boom! Love it. F prime quadratic. All right. See what you can do with this next one. Graph of the absolute value of x. I want to blow your minds one more time, and then I want to do it again. So look, what's that graph doing? Then what does that tell you about the derivative? Yes, we got it.
So then how could it look the same? Total is even odd.
That's because we're still in the baby end of the swimming pool and we've got the floaties on. You're not thinking about all the functions.
I think it's just a mistake.
Alejandro's got some nice curves.
So,
In a non-creepy way, Alejandro.
where at?
Nice, nice. Now give me derivative stuff. All right, let's close this out in 5, 4, 3, 2, and 1. I want to get some hands on this. Things that you know about the graph of M. Hold on. And what it tells you about M prime. How about ladies up front? You guys were a little quiet. So far. Things that you know about the graph of M. I'll take anything from any one of the 4 of you. There's a relative minimum. Where? This guy right here? Completely agree. Now, I heard some other folks classify this another way. They called it a relative min, and what else did we call it? Wonka. It's a cusp point. So if you go back to your notes, if I have a relative minimum, I know that f prime makes a change, right?
Yes.
Cynthia, what's that change?
From negative to positive.
We're changing from negative to positive, and I have a cusp point. So the other thing,
It doesn't exist.
f prime doesn't exist. So f prime does not exist. Boom! 2 things. What? Ooh, thank you for making me a better math teacher. Even though we have new friends in the room, I'll remember that when I write your letter of rec. Thank you. I'll talk about your bravery. Okay. Other things we know about this graph.
Yeah.
The graph was M, yeah. Other things we know about the graph. Oh gosh, I'm going to go for victims. Fabricio.
It's decreasing.
I'm sorry, what?
Is M of X is decreasing.
M of X is decreasing over here, so what do you know? What do you know about the derivative? M prime is
Below the
negative, which means when I graph, I'm going to go below the x-axis.
Yes.
Cynthia, what about over here?
increasing. So
Increasing, so M prime
Positive.
is positive. Now, I want you to look at this graph a little bit closer. Not only can you tell me that it's increasing, I bet all of you can tell me exactly what the slope is.
1.
Careful. Careful.
Doesn't.
Show me on your fingers. What is the slope here? The slope here. Yes, you're going to have to get creative here. The slope is -1. So M prime is equal to -1 over here, and over here?
1.
+1. When I go to make my graph, I need the derivative to be equal to -1 until I get over here. And then it doesn't exist. And then it's equal to +1 forever. I can see the light bulbs are going off. Melissa's like, I know this graph.
Isn't it the absolute value of x over x?
That is, right? This is a familiar graph. Janaea, one more time. What is it?
Oh, it's the absolute value of x over x.
Boom. There is a brand new derivative rule right there served up for you. The derivative of the absolute value of x is the absolute value of x over x. Don't worry about that right now. We're not worried about derivative rules. I just want to blow your mind with the beauty that is all this stuff. Okay? All right. I want you to take 4 minutes. If you flip over to page 3, there are 3 more functions. They're not all parent functions. All I want you to do for the next couple of minutes is get some feedback from the folks around you. I've given you the original graph. I want you to sketch the derivative. If you need any help, the youngest person at the table is in control of the cups. I'm only going to come over if your cup is on yellow or red. Want to go hang out with my new friends?
Okay.
So,
There's 3 roots.
Yeah.
There's 2 relative min.
Horizontal tangent line, horizontal tangent line, horizontal tangent line. What do you know for sure is happening with those horizontal tangent lines? F prime is going to have a root. If the original function has a horizontal tangent line, can I see your graph? Perfect. Yes. And units that you don't have. I think we just ended the one that you Nice curves. Right? Love it. Good curves. Good curves.
Oh, it's almost right.
Good.
You just want to let me finish.
In a minute, yeah.
This one? Because you're gonna help on that one, and I did even help on that.
Okay. So investing in this, analyzing this first graph. I'm looking for like horizontal tangent lines. Change my numbers. Good. Graph is decreasing. Negative. How far negative do you go? We don't know. That's not.
They're gonna put the one.
I know, I was just
But based on what you know right now, right now,
like a whole year.
this is the place I want you guys to focus on. Nice. Put some arrows on that function. I love it even more. It's quite cool. It's not really a question. Just wanted to tell you guys did a great job. This graph looks wonderful.
Wouldn't it just be the opposite? Wouldn't it just be like this, like the opposite?
Oh, it's not. Boom! There's another one. Keep going.
So
I know you want it to be. I know you want it to be. All right, when I say calculus, you say ready? Calculus! Ready! Calculus! Ready! Oh, that was so sad. Josue, can you head on back to your position, please? Everybody else, I want you to take your calculator out. I want to blow your minds a little bit more. It's not gonna hurt. It's fun. We love having our minds blown on a regular basis. Unless you don't want me to show you how to sketch a derivative graph on your calculator.
Yeah, let's do that.
Let's do that. Okay, Josue, the program's up. All right, my smart board. Okay. So, for the first function that we were just looking at, which was the, what, x cubed minus 3x squared plus 2? Graph that first one on your calculator. X cubed, yeah, the first one, x cubed minus 3x squared plus 2. And this is the class that everybody has in Inspire?
Yes.
Okay, good. All right, so on your calculator, x cubed minus 3x squared plus 2. Oh, careful, yep. So Mike, because we have 3 it's voice activated. Yeah. X cubed minus 3x squared plus 2. Give me a quick thumbs up if that matches.
Yeah.
Okay, we're good? Okay. hit the tab button. We are going to generate the next graph. The graph is the derivative graph. So here's how we're going to do it. So there is this little button over here. It's next to the thing that I think looks like the Bible, but it's not the Bible. This is your templates button. So click on the templates button. Anybody see anything there that makes them think derivative? Anything that looks like derivative? Cassandra, what looks like the derivative to you?
Of the 3 over